Good afternoon, everyone. Thank you for joining to this session. It's quite packed. It's fun. So my name is Ben-Alta. First name Roy, last name Ben-Alta. I'm based in New York. I'm a business development manager at AWS. I've been with AWS almost 3 years. I started my career in AWS in our professional service team, helping customers to build data and analytics or big data and analytics, but we have different services that most of you are familiar. But this is a deep dive session, so I'm going to cover some real-time streaming overview, talk about a little bit about use cases, but the majority of the content will focus on deep dive into Amazon Kinesis platform. We'll talk about streaming data ingestion and streaming processing, and we'll use the time for you to have Q&A. So just hand check. How many are using Kinesis today in this room? Okay, we have. Okay, great. How many are not using Kinesis? So that will be the rest. Yeah. How many are using Kafka? Okay, great. So I will try to. The reason I'm asking, I'm trying to use the concept and acronym so you'll be familiar. But let's start. So we'll start about like 4 or 5 years ago when customers using data and analytics, really the trend was about batch processing. We build an Hadoop cluster, we ingest data using Scoop, bring data from different sources, running clickstream analytics. Then after our ETL, we have some nice reporting tool and have the business access to that report. What happened is that the business wants to move fast. And it's not enough to get hourly server logs aggregated and get some visibility or insights, but you want to know what happens now. You want to build a fraud detection system. Regardless of which vertical you're working, real-time become really the factor of how we want to move our business now and analyze our data set. So it's all about really the pace of processing data and have a really quick response time to our business challenges that we have. There are 3 main verticals that we identify and scenarios that happens across verticals, whether it's Internet of Things or digital advertising, gaming, consumer online. And there are 3 types of scenarios that are very common across this vertical. So the first one is the first column you see, the accelerate target transform load. You have streaming data that comes from different sources. You batch them, and then you store it on S3, you store it on HDFS, you store it in some persistent storage. Many of the use cases, this is what customers are doing. They're using Kafka, they have a consumer and batch it into HDFS, or using Kinesis, load it eventually to Redshift, but before that they store the data on S3. Other type of scenarios are really how you continuous building metrics generation. You are in gaming, you have a nice gaming, you have many consumers online gaming, you want to build a leaderboard or the top 10 players, you want to start aggregating in a near real-time manner and show some aggregation. So you can look at IoT, you have many devices spread it around, you want to start measuring the operations, how the devices are behaving, you might want to do a proactive care to identify trends. And the last type of scenario is responsive data analysis, which is really the holy grail of machine learning and all the hyper on data scientists, is really, okay, I know something is going to happen. How can I now have a smart system that build a recommendation engine? You're on the website, you add something to the cart. Can I offer a customer cross-sell another article based on the events and the streaming? And these are getting more and more traction. However, still, the first one of accelerating ingest transform load is where many customers are still focusing on that. But I will show you different customers that are using different use cases, and this is the only customer deck that you will see. You don't need to take pictures of the slides. All these references, they're going to be distributed with you for links with the content around. But I'll talk about, for example, Hearst. So in the morning, we had a session with Hearst Publishing, where they're analyzing 30 terabytes of clickstream data, and their business requirements was to have the time to insight from the time. They have 300 plus websites, and they're ingesting different clickstream data from their consumers and readers of their articles and magazines. And the business wanted to have a visibility under 5 minutes from the time that anyone is doing something on the website to the time that their dashboard, they're using Elasticsearch, that it will be available for their editors. It will be under 5 minutes. So how you take such amount of data with different, that every data sets can have different fields and consume that in a way that the business eventually can take action and can analyze the data. Nordstrom is another customer in the retail space. They build their recommendation team build an online stylist using Kinesis and Lambda. That means that they have a serverless flow on their website. So every time you want to schedule an appointment with a stylist in their store, you use their system and all the events that based on the questionnaire that you're filling, it just pop up and you can schedule an event. Sonos in the IoT space, they run a near real-time streaming analytics on device data. So for the hi-fi audio equipment, they are capturing all the information. Of course, customer needs to opt in to make sure that they can capture the data, but they want to improve the customer experience of how customers are using their products and articles that they are building. Glue Mobile, it's in the gaming space as well. They're, they need to ingest millions of events from user devices, from different mobile devices, and they need to consume the data and analyze it in every single day continuously. The challenges in streaming data in general, for those that you're familiar with, is not about the volume, it's the variety and velocity. This is really the main challenge, because data can be in JSON format, Avro, Parquet, like different formats that you want to analyze, MQTT in the IoT space, and also the velocity. Sometimes you have 100 fields, you have 20 fields, and you want to be able to process in a very generic way every data records that you are ingesting into the streaming processing. So if we're talking about design patterns, there are two main processing patterns. The first one is I want to have a real time. When I say real time, I really mean on the sub-seconds, time response time. We're not talking about high frequency trading of 1-digit milliseconds or nanoseconds, but you want to have the sub-seconds response time when something happens in the system. So for example, there is a hardware error in your device. You want immediately to respond to the customer, to send an email if something. You want to do a fraud detection. The other one that is very popular today, especially if you're familiar with Spark, that you can do a micro-batch processing. It's more in the near real time, that you can take a small operations running on a small batches of streaming and aggregate, show some aggregation of events that something is happening in your system. You can monitor, perform SLAs, and there are some customers that are using it for micro ETL of a lot of streaming data. So these are the main processing patterns. We'll get that in the following slides of what processing tools you can use with Kinesis streams. So for those of you not familiar with Kinesis, so Kinesis was introduced back in 2013, and today the platform offers you 3 lines of services. 2 of them are already on general availability and general available, and one is going to be released soon. It's already in preview. We have customers that are playing, and I'll go and talk about each one of them. So the first one is the Amazon Kinesis Streams. It's for engineers. If you want to build your custom application that processing streaming data and analyze it, you will use Kinesis Streams. I will go and deep dive into Kinesis Stream. What does it mean for you? If you want, what does it mean to build a consumer application? Another service that we launched in reInvent, it's Amazon Kinesis Firehose. You don't need to be an engineer to use Kinesis Firehose because you don't build any custom application. You go to the console, you define a delivery stream, and today with Kinesis Firehose is an ingestion process that you can load data, ingest streaming data into S3, into Amazon Redshift, and as we announced today, another endpoint is Amazon Elasticsearch. Amazon Kinesis Analytics provide you a way that you can build an application using fully ANSI SQL, so you can run query on your Kinesis streams and analyze your data based on plain SQL code. You don't need to write a Scala code or Spark. You will just need to build an application using SQL. I will start with Kinesis Firehose. So we launched Kinesis Firehose in the last reInvent, and today we added the new endpoint, which is Amazon Elasticsearch. We're very excited about that. Many customers are using today Elasticsearch with Kibana just to have a dashboard or something that for customers to start searching data on the Kinesis streams. So the idea with Kinesis Firehose is that you have a direct to data stores integration. For example, if you set up a delivery stream, you can say, I want to aggregate the data from 1 megabyte to 128 megabyte. You can define how I want you to encrypt the data. You can use KMS and land the data on S-read encrypted. And you can also set up the compression algorithm. We support gzip and LZO compression as of today. You don't need to admin. That means that it's scaled for you. So for example, if you have thousands of events per second, or you have 10,000 of events per second that you want to ingest with Kinesis Firehose, it will seamlessly scale to match your throughput without really intervention. So that's the Kinesis Firehose for ingesting. On the other hand, Amazon Kinesis Streams, for those that are not familiar, the idea is that you have many-to-many relationship. You can have multiple producer of streaming data, and you can have multiple consumer that consume the data. So for example, you can have a click stream that comes from your mobile device or your web pages going into Kinesis Streams, and you can have multiple applications. You can have one application that can aggregate the data stored on S3. One application can be a sliding windowing that you want to have a dashboard that shows you in real time all the metrics that you want to capture. You can apply machine learning, and each one of the consumer can read data from the stream without really impact each other. That means that the impact only is regarding the throughput. And the way Kinesis Stream works, we have the concept of shards. So if you're familiar with Kafka, in Kafka we have topic. In Kinesis we have stream. That's a topic. We don't have brokers. We have shard. Shard is the capacity unit of stream. So every shard have ingress of 1 megabyte per second or egress of 2 megabyte per second. And according to the throughput that you want to provision, depends on how many consumer you have, you will set up how many shards I need in the system. Now, because it's fully managed service for streaming, we don't want you to lose data. You don't want to lose data. So every data that you put into Kinesis Streams is replicated across 3 availability zones. You have replication. That means that you have the data there. And you can also have what we call a replayable function that you can go into the stream. And this is illustration of how it used. So up until last year, data was stored in Kinesis only for 24 hours. The good news is that you have the data available for 24 hours. The bad news is that you have 24 hours to process all your data in Kinesis Streams. But sometimes you have one consumer that needs data every 1 hour. Sometimes you have a consumer that just need continuously processing the data. At reInvent, we added a new feature that you have an API that you can do an extended data retention in the Kinesis Streams. So you can have it from 24 hours up to 7 days. You add another 2 cents per shard hour when you use that. But the good news is also that you can disable it in any given time. It's very good if you have a large-scale event that you need to have processing this amount of data, and you think that you might have a backlog, so you can just turn on and have the data extend more than 24 hours. So this is the concept of shards. As today, we announced also the approximately timestamp that you have the server time. So now you can iterate across the streams based on timestamp, not just sequence, which really gives you more flexibility. For example, I want to look at data that comes from 7 a.m. or 7:30 a.m. based on the timestamp. So it's much more convenience for you how to iterate. The notion of replay, so every consumer can go and back in time on the streams and read the entire streaming data, because every consumer have different pattern. It really depends on the use case. And we will go to the deep dive. I will share with you what you want to think about when you design a streaming data system with consumer. A very common questions we are getting, okay, when I should use Kinesis Streams and when we can use Kinesis Firehose. And the difference are really mainly about how the consumption of the data should look like. So you will use Kinesis streams. It's for use case when you're required to have a custom processing and build an application. That means that you want to have a sub-second response time, processing the latency, and then I want to build. So for example, we have customers that are using Storm with Kinesis or Spark streaming with Kinesis. You will use Kinesis Firehose only when you can tolerate data latency of like around 60 seconds or higher. And you don't need really to have the sub-seconds processing time. But you can use both. We have customers that are using Kinesis streams to store all the raw data, have a Lambda function that is triggered per put event, and Lambda function can trigger Kinesis Firehose and put the records to archive into S3. So we start seeing this trend of building a pipeline of streams, and the idea is that you don't really need to manage EC2 instances, and I will talk about Lambda in the following slides, on the following slide. So let's talk about streaming data ingestion. So how you put data into Amazon Kinesis streams and Kinesis Firehose. So one thing you want to remember, in Kinesis streams, you have the concept of a partition key. Partition key is actually the, you have a partition hash range that when you land the data into the shards, it's based on the shard range that the Kinesis stream is doing MD5 hash per the partition key. So if you need high cardinality across your shards, that means that you don't really care about ordering and you want to spread it across all shards, just use a random number of partition key. Make sure that you provision adequate number of shards. Let's say that you estimated that you need 10 megabytes per second and 20 megabytes per second out. In general, you can have 10 shards that will give you that throughput. We always recommend that you take some headroom to catch up with data in the streams, although you can extend the data retention. But let's say that you have an urgent requirements for another unit in your organization, and you need to build another system that can consume the data. It means that you add another consumer that can run in parallel and processing the same data. So you want to have that headroom. Although we have tools for you to be able to what we call split or merge shards per your needs. In order to put data into Amazon Kinesis, so we introduced Amazon Kinesis Agent. I don't know if you're familiar with it. 2 weeks ago, we added support for pre-processing. It's an open source available in GitHub. The way it works, you provision an EC2 instance, you have an Amazon machine image, and you can take any log files that you generate and just render, and it will, this agent will act as a listener to the log file, and it will stream the data into Kinesis streams or Kinesis Firehose using our API. Other options, if you have like collectors that running in your data centers, or you're using Flume or Fluentd, there are connectors to Amazon Kinesis. They're also available for you in GitHub as well. And you can make tweaks to your existing logging. So if you're using Log4j, all you do, you can take our jar, just add it to your Log4j, update the property file, and everything that you render into the log file will now add to Kinesis stream. So you can build your own logging and operational monitoring. Amazon Kinesis Producer Library, it's another option for you to put data into Kinesis streams, but it was built for those that have really massive amounts of events that they need to process. So you can use Amazon Kinesis Producer Library. It's an open source. It was written in C++, but it has a Java interface. You can have it, and it aggregates all the records before you put into the Kinesis streams. The reason you might want to use it is because when you use Kinesis streams, there are two dimensions into the pricing. One is the shard hour, and the other one is the payload. For every million puts, you are paying 1.4 cents per million puts. However, what we're taking into consideration that every record is 50 kilobytes. So let's say that your events are really small, like 5 bytes or 1 kilobyte. Sometimes it's better for you to aggregate before you put into the Kinesis streams that records. Now, the thing is with Kinesis Producer Library, you need to run it on an EC2 instance, you need to run it on a server and machine, and then in order to deaggregate the records, you need to use the Kinesis Consumer Library. We added very recently a support with Lambda. So now you have KPL, Kinesis Producer Library, available with AWS Lambda. So you can do both aggregation and deaggregation using Lambda without really managing EC2 instances, which is really makes a lot of headache go away from your side. One tip is just make sure that you have enough memory, because Lambda has, you can pick a different set of memory for each function when you define them, and so you might want to, and it's based on the number of records that you really aggregate. So for example, if you have 1 GB that you aggregate, you might get a scenario of out of memory, so you want to make sure that you batch it in the right way. Also, Amazon Kinesis Producer Library provides you CloudWatch metrics. That means that you can look at your performance of your puts of the records. There are several very valuable metrics that you can look at the system and measure it. Now, that's another interesting topic about ordering. So the streamings are ordered when we insert into Kinesis. Now, the question is, if we define the partition ID that is randomly, it will be across all shards. So if you don't really care about ordering of the data, so for example, you just want to do a count by something without really care about this ordering, so you can just randomize the partition key. If you want to have the exact order of processing, you want to control your partition key, then you can control the events, how they are grouped into the same shard. And when you have the concept of worker and you're reading the shards, you're reading from the Kinesis stream based on the partition key from the shards, you will have an order. An example I can share is that, let's say that you have add to cart activity on your e-commerce site. And that specific category of sets, you want to make sure that you want to look at the synchronization, like what article or what product I added to the cart first. So this is, for example, a way that you will have a partition ID that is based on the business logic of add to cart. And all these events will actually get into the same partition range key, and then you can process them in an order way. If you need both, you will need to build it from your application perspective a global sequence number. We have customers that use DynamoDB to store that, so that's another option for you to store that. So we talk about how you scale. So sometimes you need more shards. Sometimes you want to reduce the number of shards. You have a tool in GitHub that allows you to split and merge shard. This is a Java program. You can invoke it programmatically in your system that allows you to split and merge shards. So you will split shards if you need more capacity. The way it works, it's based on our code. So one of our great solution architects, he built that utility. So you run it, you provide the stream name into that tool and the scaling action. So for example, you want to scale up, scale down, or resize. You can also provide a percentage for how much percent you want to add, for example, like how many shards you want to add into stream or how you want to shrink. So the way it works behind the scene, while you're doing it, you can still be able to read and write from Kinesis streams. You don't need to take the system down or anything. It's still running, so behind the scene, it redistributed the data across the shards, but you will still be able to read and write from the Kinesis streams. So let's talk about how you do the streaming processing, because really this is eventually, okay, now we have Kinesis, it's managed, we take care of all the high availability, durability, but now, okay, what I'm doing with streaming data, and this is where it becomes really interesting. So the first option is to use the Amazon Kinesis library. The Amazon Kinesis client library, it's open source. It was written in Java, but we are using the multi-lang daemon, so you can use Node.js, Ruby, Python, .NET to read data and process data from your Kinesis streams. You deploy it on EC2 instances. That means that if you need multiple EC2 instances to read from this entire stream, you can put it under auto-scaling group and then scale up, scale down based on the throughput that you are requiring. And there are three components within KCL. The first one is the record process factory. that it's a factory that you can create all the interface, all the objects of Kinesis record processor. And record processor, that's really the business logic that you write to process the data into from Kinesis streams. You have a worker. It's actually mapped to an EC2 instance. That's the processing unit that maps to each application instance. So for example, if you have application 1 that has a fleet of EC2 instances, you have a multiple record processors that are processing the streams with the shards, and you can have many of them. So one of the scenarios that can happen is that, let's say that one of your EC2 instance died, one of the worker died, you'd still want to be able to recover. So what's unique about Kinesis Client Library? It comes with state management processing, what we call checkpoint. So behind the scene, if you use that, you will see if you go to the console and you look at DynamoDB, you will see a table. And usually the table name is the name of the application that you built. So one record processor, it maps to one shard, and it processes the data records from the shard. So for example, you have a mapping in the table, you have the name of the shard, you have the hash range, and you have also the checkpoint, like what time. So for example, let's say that host A died. Immediately when a new host will come, it will pick up from the table where I should continue to read the processing. It also allows you to balance the shard worker that associate with the shards. If you're running a split or merge, that also updates that table so you can know where to start or continue to process the records. One of the things that we see with customers is sometimes they have issues and they call us and say, what happened? Apparently, the name of the table is unique. So make sure that you don't give the same application name to if you have different consumers, because that can create problems because it's unique. So you have the name of the table is unique for the application ID. So other options that you have, so you can use third-party connectors. We have also connector library. So if you're running Splunk build the connector to Kinesis. With Kinesis, we have third-party like Qbuild, Databricks that also have integration with Kinesis. Our AWS IoT platform has integration for the rule manager there with Kinesis Streams and Kinesis Firehose. I'm going to focus more about Lambda and EMR, especially with Apache Spark. I'll show you a demo when we talk about Apache Spark. But how many are familiar with Spark? Oh, great. Well, 3 years ago, if I will ask that, there will not be so many hands raised. So Spark is a distributed computing engine. The difference between MapReduce paradigm, it's running in memory. You have the concept of resilient distributed data with Spark. So thanks to our friends in Databricks, they come up with ASL connector to Kinesis. So you can use, with Spark, you have Spark SQL, you have the Spark Core, and you have Spark Streaming. So Spark Streaming can read directly from Amazon Kinesis Streams, and you can do a micro batch and processing the data. Many customers are using it for doing a micro batch ETL, but not only that. So think about with the concept of Spark, when you have data, let's say that you have a flat file on S3, and you have data in Kinesis Streams, you can have two RDDs and do a join between them. You can have Spark reading from multiple Kinesis streams as well and join the data within Spark. So the way you do it, you just go to Spark, you build it with Maven. Make sure that you're using the latest KCL version because we are upgrading the version as well, like if some bug fixes, etc. But make sure that you just update the POM XML with the latest Spark version. So a common workflow, if you are using, for example, Redshift as your data warehouse, and you're doing streaming data ingestion with Amazon Kinesis Streams, and let's say the streaming data is really messy, it means that you need to do some ETL or building a tumbling window. So you can use Apache Spark with EMR, and I'll show a demo how it works. And then you can actually directly take the output and copy it into Amazon Redshift. So some customers like to have the output back to S3, but you have the option to copy it also directly from EMR cluster to Amazon Redshift. So you can just run the copy command instead of table issue from EMR cluster and just give the cluster ID. So that's a common integration pattern. Other use case, you can build a real-time dashboard of tumbling window when you want to look at thresholds, etc. So you can do that as well. Some tips, and I just capture some of the recommendation when you use Spark Streaming with Amazon Kinesis Streams. We published, I think it was a month and a half ago, a great post on our big data blog about how you optimize Spark Streaming with Kinesis Streams. There are some configuration around Spark executors, those are familiar that you want. So, and you have the link later on that you can read the entire blog. But make sure that you use Spark 1.6 plus with EMR FS. Right now with EMR, we support the latest Spark version, so it's 1.6.1. EMR FS provides you to have a consistent view option. That means that you can look at S3 as an HDFS. Especially it's important when you want to do the Spark has its own checkpoint. It's different than Kinesis checkpoint. So to maintain that checkpoint, in S3 you have the eventual consistency. EMRFS solves you that problem that you can really treat S3 as an HDFS, and you can do the checkpoint with S3 every time you need to do the checkpointing with Spark. Amazon DynamoDB table. Make sure that there is always one instance of your application running with Spark streaming, especially because of the table names I mentioned. So sometimes we have customers that have multiple EMR clusters that they brought up, they are running, but they didn't change the application name, and now they have some issues with that. There is a feature in Spark based, so you have a configuration, you just need to make sure that it's enabled. And other recommendation are the number of executors you want to have as the number of cores per executor. So it depends on the EC2 instance that you pick in EMR. So with Spark, we really love to work with R instance type. They're more expensive, but they are very memory optimized and very good for Spark. We met customer today that is using M3 and they change it to R and they saw better performance just because you want to leverage the memory optimization. Also make sure that Spark Streaming uses default of 1 second with KCL. So you can define, I'll show you in the demo that you can define 10 seconds, so how much time you want to do the buffering. You can do like windowing, tumbling every 10 seconds, every 5 seconds. So the default is 1 second. So sometimes you want to change it because in 1 second, you have this amount of records. It really depends on your producer. So I'll show you the demo, and this demo, it's a recorded video that we presented in the latest Strata. The idea is that we build a simulator that do 20,000 events per second, and it's mimic like a device and the temperature and the timestamp, and we're using Spark Streaming to process, and then use Zeppelin, which is a notebook, to process the data. So we build with Java a simulator so that you start pumping Kinesis streams with 20,000 events every second. If you go to the Kinesis streams, we give it the name Spark Demo, but in the console, you can look at the CloudWatch logs, so you can look at all the total incoming records and different metrics to see live how many. We provision 20 shards for that amount of data, and then we create an EMR cluster. When you create the EMR cluster, so this is the 4.4 version. You pick up Zeppelin, for example. If you're not familiar with Zeppelin, it's a really cool tool for you to interact with data. There are many common notebooks like Jupyter, but Zeppelin is an open source. And now with EMR, you can actually launch it from the console. So once we create the cluster and set up the number of nodes, we can now access from the console to Zeppelin. So when we go in the cluster, once it's ready, you have Zeppelin link. You open the notebook, and with the notebook, we can now interact with our data that is in Kinesis streams. So this is a piece of, this code, by the way, is available in GitHub. We just today put a blog post with all the content, so you don't need to follow. So here what we do, every 10 seconds, we pull data from Kinesis streams, and we want to build an aggregated real-time windowing and look at the data and how it's being aggregated across to look at the temperature average for all the devices per time. you can use Spark SQL to build that. So, and then Zeppelin also provides you a visualization that you can look at in real time. So we build a table, and what you can see here is that all the data is being displayed in a real-time aggregating. So yeah, it's really messy because you're doing 20,000 of events per second. But if you see, we run the count, and this is using Spark SQL. So I created a table in Spark SQL that actually the data is in Kinesis streams. I run it again, and the number of records is increasing. So that's one option for you how to interact. Spark is become very common if you're using machine learning library. It comes with the mlib, so now you can do some really interesting stuff with that. But really, it's a very robust data processing engine that you want to use. Now, for those that are not using Spark today and still are using Pig and Hive, when you use EMR, we build connectors. So for example, you can use Pig and Hive and point to Kinesis streams as well. And we have code samples on our website as well. The last processing and pattern, and this is really something that become very trendy. How many are not familiar with Lambda today? Wow, that's great, not many. So Lambda is a compute service that it runs, and you don't need to manage EC2. People really like that. But the way Lambda is triggered is based on events. So there are several events that you expose in our AWS services. So for example, put object into S3, delete object to S3. And Kinesis is one of these services that you can really use Lambda to trigger that event and process it with Kinesis. So the way it works, when you put records into Kinesis streams, a Lambda function is being triggered. Of course, you need to set up the IAM policy and so forth, but the function runs. So if you want to build a recommendation engine, you want to send an SNS based on something happening in the event, and you have 5 minutes of timeout, so that's a lot of time to process something in real time. So that's become very popular today when you want to build a serverless chain of streaming processing. And you can use both. So this is a diagram for one of the customers of us that are using this common architecture pattern that it takes data that comes from mobile, from different devices, websites. You have Kinesis streams that store all the raw data. What you see, the side data, it's a Lambda function that what it does, it triggers every record, and it's created into you using Kinesis Firehose, and it just archives the data into S3 because they want to make sure that they have archive of all this clickstream data. And that flow from Kinesis streams up to S3 through Lambda, there's zero administration. You don't manage any EC2 instance. It's like set and forget type of flow that you want to set up. On the other hand, they want to do a micro ETL, and that's where you can use Apache Spark on EMR and have the process data also stored in S3 because maybe there is another unit that needs to use that clean data set, etc. So these patterns of have multiple consumers against the Kinesis streams and leveraging different services, this is something that you can orchestrate a streaming pipeline with AWS using these services. So just for conclusion, when you think about using streams, first think if you can solve it with Lambda. That's the first tip of choice. Like if you want to see, can I do it without really managing an EC2? If do, you're welcome. If not, go to the other options. Amazon Kinesis streams allow you to, it provides you a managed service that you don't need. If you're using Kafka, you don't have the concept of Zookeeper and managing it. We're doing it for you, that you can focus on continuous processing with the systems. If you want to ingest and aggregate data and you have a massive amounts of records, like we're talking about, millions of events per second, or you have like gigabytes per second, use Kinesis Producer Library. That's really the way to do it. If the data records is really small, if your data record is 1 megabyte, Kinesis supports up to 1 megabyte. But if you have more than that, it's not really streaming data problem, like if it every record. So this is maybe you need to work in a batch mode. Process the data. Look at our connector library. Look in our KCL. Look at the ecosystem. We have many third parties that integrate with Kinesis. Determine your partition key strategy. That's important. You need to know ahead of time of how the consuming of the data from Kinesis streams will look like. So if you design it, you know, but if you don't, you can start using random, but then if you get to the point that ordering is as important, so you might want to find the logic. But sometimes have another Kinesis streams. You can have a different Kinesis, like you have multiple Kinesis streams that, for different business units. So that's another valid solution. Oh, sorry. So all what I spoke, like we don't have a lot of time, but it's everything you can find in our technical reference, and you will have that text ready to you. So we have a long time for Q&A, so thank you first. So hopefully it was not too fast. Thanks. So I want to take some questions because this is, any questions? Yes. Sorry? Yeah. You can go. There is no free tier for that service, but one shard costs you 1.5 cents per hour when it runs, but we have special programs sometimes that you can talk to our account manager. But let's say that running tweets like Twitter feeds like for 1 hour will cost you less than a cup of Starbucks coffee. So it's not expensive. Yes. Yeah, the question from the gentleman was around Elasticsearch. So Kinesis Firehose as an endpoint, now that you can ingest continuously the data into Elasticsearch. Now you have Elasticsearch to Kinesis Streams connector, but you will need to build an EC2 instance that can read it and send it to Elasticsearch. With Kinesis Firehose, you don't need to do that. All you do is point the endpoint to the document in the Elasticsearch, and it will continuously flow the data there. Sorry? So yeah, you can use Kibana. The Amazon Elasticsearch, when you launch that service, you have Kibana link as well, and you can launch it from the console. Yes?
So my question is, so we have this data source as PostgreSQL, which is my input to the ETL that we do. So is there any way you can produce data streams from the database?
So yeah, it's a good question. So the question from the gentleman, you have a database and you want to capture data change event every time you're doing an update or insert. So some database have their own logs that they generate, like read log. So you can have an EC2 instance with the agent, just listen here to the log, and you can continuously stream that with Kinesis to Kinesis Streams or Kinesis Firehose. You will need to build a consumer for that event to log it.
No, I want to actually read the data from the tables as soon as they get inserted.
So you will need to build a trigger in the table itself on RDS, or sorry, on Postgres. So we need to have a listener to that table that every time there is event, it will add a Kinesis data into Kinesis.
Okay.
Unless there is an open source that does it for you, but you will need to build it or have an agent. You can use the agent because every transaction that you have in I think in Postgres is being written into the read log, like all the logs of the transaction. So if you're using the agent, basically you can point to the same log that the database. So all the DDL, all the read, write, updates, delete will being read, so also will stream into the Kinesis streams. Okay. I think it should work.
Yeah, that sounds good. Thank you.
Yes? Yeah, so Kinesis Analytics is in preview. You can register from our website. If you have account manager from AWS, you can feel free to send him an email with your account ID, and we have customers that started looking at it as well. I don't know about the pricing yet, so it's hopefully it will be okay. But I don't have the information. It's being recorded now. It's say, oh, okay, what does it mean? Okay, but really, if you look at Kinesis, in general, the spending cost from your entire pipeline, it's really minor. It's a pay-as-you-go service. You don't need, like, we have customers, like for example, you use Kafka. What they do with Kafka, you need to have an EC2 and EBS running 24/7, and here you just, limit it to one shard or just delete the stream, and that's it. You don't need to provision that amount of data. So we don't want you to manage infrastructure when you need to deal with stream, because stream is a complex problem. Like, we can start talking about at least once, exactly once. It's a headache to manage it, like, especially you don't want to lose data. Now, there are some scenarios that customers really don't care about durability. We care. Like, the way we build it, we don't want customers to lose the data. If you trust us to, and we have customers, like, they're doing like tens of billions of events per day, and that's events are cost, like, this is money eventually. They create their bills, their invoice eventually based on these events, so you don't want to lose that. Yes?
Is there a max capacity on the fire hose? Like, if I have a stream and I have a bunch of customers sending their information, is there like a magic number or something that we should like take into considerations of how many customers do we have?
So there was the question from the gentleman, is there a maximum limit for Kinesis Firehose? So there is no concept of consumers in Kinesis Firehose, because you have the destination. You can have multiple destination, but you will need to have, you have soft limits for the number of delivery streams that you want, and also the amount. So by default, we have 5 megabytes per second. If you need to have more than that, just fill a form request. The reason we have these soft limits, we saw incidents with other services that you have a data scientist that came in the morning and provisioned 1,000 node clusters, and he left home, and then you send a bill and say, oh, it's up and running. So we want to have these soft limits to make sure that if you need to increase it, you fill a form, we talk to you, and make sure that, because we don't want you to pay too much for our services as well, so we'll look up a way of optimizing it. So for example, the topic you brought, like, we had a customer that said, yeah, we need thousands of a Kinesis Firehose with thousands of buckets. And I say, ask why? Because right now, when you set up the destination bucket into Kinesis Firehose, it lands into a specific bucket. He said, no, but I want to distribute it into a different bucket. So I said, okay, let's have a Lambda function that is triggered every time the Kinesis Firehose landed data on S3. Now I can have a Lambda function that can redistribute the data in other regions. So we saved him all this work. You can do it with Lambda. So just find the right design pattern for you, but hopefully it answers the questions. Yes?
Oh, you talked about how AWS has worked with mobile gaming companies like Glue.
Yeah.
I just want to get your opinion on the future of mobile gaming, the potential, how AWS can fit in with, like, say, theoretically millions of concurrent players competing in live.
Yeah, MMO and
I know Machine Zone's come out with RT platform a week ago or two, or mentioned that, but what do you think about the future and how AWS can fill those needs today, maybe?
So we have, like, Supercell is the Clash of Titans, like one of the #1 games is a Clash of Titans, yeah. Is a user of Kinesis, and they talk there, and you can imagine the amount of throughput and events they have every day. So we want to be part of the journey of these customers to scale. When we built Kinesis internally, it was to solve our own metering problem. So we have a lot of scalability to really support. Now, there are other tools like Lumberyard now for gaming, and that ecosystem is really evolving. And we will keep innovating on streams, because we really think, like, when you talk about the big data landscape, yeah, you have data warehouse, you have BI, but I think as we move on with the technologies, business really don't care what happened yesterday anymore. They care what happens now. And the rest is really history. It doesn't really promote their business value. So this is why we come up with Kinesis Analytics. One of the tenets was, what is the common language that analysts are using? And it's SQL. And running ANSI SQL and building a custom windowing dashboard running SQL instead of writing it with Python or Java, it's much easier to do it with SQL. And we'll keep doing that, because first, it's what you are asking from us, like all the features and and additional stuff that we are adding to our ecosystem is based on discussions with customers and what they're asking for us. They want to focus on innovating and building products and not really managing this infrastructure. So that's really the motivation behind the managed services. Yes?
Do you guys plan to integrate with tag management systems like Signal or Google Tag Manager?
So I can tell you, like, for example, Hearst, they work with tag management called Ensighten. The way they did it, they implemented JavaScript on all the pages, and Ensighten just took the JavaScript, and they use Elastic Beanstalk to trigger, to have, like, serve it as a Kinesis proxy. You know the pixel trick that you're doing send a get with pixel, and you concatenate the entire string. What we see now, customers are using actually API gateway. So you can use API gateway and send a 200 response, and that API gateway can trigger Lambda or can actually use Kinesis to load the data. And I think this tag management system will adopt to that. So we made it easier for them to integrate with our APIs. So of course you can use SDK to push data and like everything in AWS, you have API, but we make it easier for them using API gateway because that hopefully it answer your questions, but they are building, like I'm working with other vendors now on they want to build a connector, so yes. Yeah, so you're talking about more the network streaming, like packet inspection. So these are use cases. It really depends on the latency. Right now, to be honest, our propagation delay in Kinesis streams, we are on 300, 400 milliseconds response time, latency from put to get. If you need the 2-digit, 1-digit, you know, there are other solutions today. We want to drive it down. I'm not sure that we'll drive him to the 1 milliseconds or the nanoseconds. That's a different business to be in because then you need to really work on sometimes on the bare metal of the network piece. But for really the sub-seconds, that's definitely, many of the use cases can be filled. So I would love to hear more about your use case. Like there are, I don't know if you know Apache Apex and things that you can have the 1 digit of milliseconds sometimes. So. But we just want to be open. This is where we are now. But we want to drive the latency lower and lower. So, yes?
One of the limits on the documentation for Kinesis is 5 consumers per second.
Right.
Is that a hard limit or a soft limit?
Right now it's a hard limit, and we are thinking to increase it. It's something that is on the roadmap. Right now it's a hard limit. There are several reasons for doing that, but just add more shards, but we are going, like it's something on the roadmap. Like it's, I understand where you're coming from because when you have multiple consumers, you just want to have the latency, you don't want to pay more, but yeah, right now it's a hard limit.
My use case for higher limit is use it as a message bus for my entire
Right.
architecture. I can't do that.
Yeah, so sometimes like what they do, like use SQS, for example, and when you need to message, and that's the difference between queue and streaming, like different use case. But we see this type. Yeah, thanks for the comment. Yeah. Anything else? Guys, thank you very much for joining me late in the day. Hopefully you enjoyed and learned. And I'm here if you want to ask me a question offline. Thank you very much again.